that, I'll pass it over to Mike, and it's all you.
Thank you very much, Phil. And thank you all for attending. So we have a good list of people that we see here on the line, and I expect that to fluctuate as we go through. I'm going to get the screen share started. Today, we're talking about drill down summary tables in Shiny with T-plier. So we're going to go through. I'm really excited about this. And Eli, can you confirm for me that I'm sharing the slide deck?
Yep, you are.
Make sure that I share the right screen. All right, because Zoom puts it on another screen. So we're going to be talking about a package that we created called T-plier. So just to introduce myself quick, and I'm also going to add that this is Stackhouse, Eli Miller, and Andrew Bates. So my name is Mike Stackhouse. I'm the Chief Innovation Officer of Atorus Research. So we, as Phil mentioned, we work actively in the R world for clinical reporting. We've been at this for a couple years now, and the package that we're presenting today is something that we originally released in 2020, and we've talked about it quite a bit, including at R Pharma. But the exciting part today is that we have new features that have come out, and we're actually pushed to CRAN about 2 weeks ago or so. So you're getting to touch the latest things that we've dropped and that have been in development, and try to see some of the cool features of how we're trying to help take summary tables from the page to the screen. So again, my name is Mike Stackhouse. So I have Eli Miller with me. Eli, can you introduce yourself quick?
Yeah, absolutely. My name is Eli Miller. I, along with Mike, designed T-plier after we kind of noticed there was this gap in the space for clinical tables. I am active in a whole other host of open source projects. So yeah, I'm definitely grateful that you're all here and you're ready to take a look at what we have for you with T-plier.
Thanks, Eli. As he mentioned, Eli and I are the primary authors of this package. So if there's anything that you like about it, we are happy to hear it. If there's anything that you don't like about it, we're the people that can do something about it, as we're the active maintainers of the package. So we love feedback, and we love to hear what works and what doesn't. Additionally, I have Andrew Bates, who's going to be joining us later. He is in California, so a 6 a.m. start was a little rough, but he's going to be joining us in here. Andrew is one of our highly talented Shiny developers. He did some of the review that we had of the latest features that we've introduced, and when it comes to Shiny, he is comfortable bridging that world into JavaScript, and all the cool things that you can do to really get the most out of Shiny. So I wanted to bring a decent team of people that can help you out here today. Like Phil mentioned, as we go through, the way that we're going to conduct this is doing some lecture, teaching you about the package, and then we have breakout sessions where you're going to do some hands-on programming. And one of the first things that I'm going to do is walk you guys through a little bit of what that setup is going to look like to get you working. But the goal today is to get you coding, to get some hands-on experience. We're working with T-plier so that we're not just talking at you for 4 hours. So this does go from 9 a.m. Eastern to 1 p.m. So we have a really large chunk of time here, and my experience of doing this is that we're going to use it. But we want you guys to do hands-on work, and we want you guys to get a feel for how this package actually works itself. All right. So as some prereqs for this workshop, we do make some assumptions about the demographic of people that are in here today. And this is just to let you know the level that we're going to come in presenting. I am happy to answer questions always. So if you drop questions into the Zoom chat, this is one of the reasons that I have TAs here with Eli and Andrew to help, because they'll be able to, while I'm talking, answer questions for you, provide references, and help you out. Additionally, we're here to help you with the working environment that we'll build here today. But as some backgrounds that we're assuming of you as attendees, the information is going to assume that you have some sort of background in creating clinical tables. So the language that I'm using is going to be talking about pharmaceutical tables, and those typical tables that you're producing that are going into your clinical study report. We also assume that you do have a working understanding of R. They understand the RStudio IDE itself. I'm not going to give a huge long overview of that, but I will introduce you to RStudio Cloud, which we'll be using for the environment. Because of the package tplyr, I am going to assume that you have some understanding of R objects such as vectors, lists, data frames, and some of the differences of that. If this was the SAS programming workshop, I would bring the language about objects way down and try to present it in terms of for SAS users, but we're going to talk about things like list columns and data frames, vectors, data frames, etc., in that R language. And then additionally, that there's a basic understanding of user-defined objects and using things like S3 methods. We're not going to be creating any S3 methods, but the functionality of how some of this works is going to help you understand what I'm talking about. Additionally, a working understanding of Shiny. So we're not going to do advanced Shiny development today. The focus is actually going to be on tplyr and how it interacts with Shiny to show you how you're able to leverage this. And the last two breakouts will be some really basic Shiny apps that we've created some templates for you to work from so that you can work with that. But in that, a working understanding of reactive elements and the UI server relationship is going to help there. So pretty intro level Shiny stuff for this so that you can just kind of see how this works in the context of Shiny itself. All right, so for the agenda, what we're going to go through is the intro and motivation of what we've done, what we've created in tplyr itself. And then going through, we're going to take two sections to go through some of the fundamentals of tplyr. We're not going to go in depth into how to use it itself, but help you understand the basic syntax if you've never worked with our package before. So we're going to go over the basics first to give you some of the fundamentals and understand how tplyr summarizes data, and then do a breakout section to get you into the RStudio Cloud environment. That's where we'll help you out to make sure that your environment's working, and take a little bit of time in that section to make sure that you guys are up and running with the working environment. We're going to go through configuring tplyr tables and how you can extend and customize and use some of the configuration tools that we have in tplyr to help you make the table that you want to create. Go into another breakout and get you guys some hands-on experience working with that. In breakout, in the next section, we're going to introduce the metadata concept of tplyr and how that structure works and how you interact with the metadata behind tplyr. And this is what enables the drill down capabilities that we wanted to demonstrate within this workshop today. In breakout 3, we're going to walk through that. We're going to help you understand how that interaction works, how tplyr builds metadata, and how you're able to interact with that metadata to get that drill down functionality of being able to look at a result and say, this is the data that was input, and to compute that result in the first place. And then in the last two breakout sections, we have some Shiny applications at a basic level that will put you in and show you how working in the context of Shiny, how the tplyr table enables you to talk between a click event and the user or the server so that you can get that click-through capability to enable what that drill down functionality looks like. So to get things started, I'm going to paste some links that are going to be useful throughout the workshop for you guys. So first off, if you have not created an RStudio Cloud account, please click the link that I just put into the chat. What you're going to do is come over here and click Get Started for free. All you need is the free tier of what we have here, so nothing special, coming in and create that account to get an RStudio Cloud account and get yourself logged in. Now, this is honestly typically one of the hardest parts of the workshops when I teach them, because if you haven't created this, what's going to happen is you're going to create your account. It's going to send you a verification email. You're going to acknowledge the verification email and then come back and you're good to go. If you're working from a company laptop and if you're trying to send and make your account through a company email, that verification email can sometimes take a little bit to get through the company servers. So just make sure that you're going in and that you're creating that account now so that as I go through the intro parts of the lecture here, that you're all ready to go. And we want to make sure that you're logged in and ready to go so that I can add you into the workspace that we have for today. So that's the first thing first. So if you guys can go in, get that started, it's going to help us move much more quickly as we go through this today. All of the breakout material, you do not need to clone this, and I'm just giving this for you as a follow-up, but everything that we're going to use today is public on GitHub. So if you don't want to use our Studio Cloud as well, I did put in a Renv environment for you so that you can instantiate this and get everything up and running with the right set of packages in your own environment. But we have this GitHub account or GitHub repository that is available for you. There we go. That outlines everything that we need here. So that is for follow-up and so that you can reference the material outside of our Studio Cloud. Additionally, this is the package website for tplyr today. I have a number of links throughout the breakout sessions that will lead you to some of the material that's in our package website so that when you're doing any work on your own, you understand that. But assuming that you've worked with other package websites like tplyr or anything in Tidyverse, we have a number of different vignettes that are available to go through different topics. But we also have all the reference pages for all the functions that are available in tplyr today. We're going through the more basic set of modifiers and everything that we have in here, but there's a pretty large suite of functions available for in here for you guys to customize the tables as you're producing them. So we have those 3 links. So once you get your verification email and you are logged in, then I'm going to get the sharing link. So once you have your account and once everything is created, that is the link giving access to the workshop. So you can click that once you're logged in RStudio Cloud, and it will give you access into the environment so that you can create your own account. And once you get in there, all you really have to do is find this project that's labeled assignment. It'll have my name on it. So if you're having any trouble following it or finding it, you can type in Mike and it'll filter to give you, or I guess that doesn't work. But finds the assignment. I can see Ankur. You've already done what you got to do, so you're good to go there. When you click this assignment link, what it's going to do is create a copy of the work environment for you today. So that'll get set up. This environment's already pre-configured and ready to go. We have the GitHub repository cloned in there. We have all of the packages that you need installed. It takes a little bit to boot up for the first time because it's creating a copy of the entire environment for you. But once you get in, your page is going to look something like this. So you should see the breakout sessions over here. All right, if that's labeled start for you, it's good to go. Thank you, Pascal. But what you're looking for is my name or some sort of tag next to that. And a lot of you are doing this already, so that is great to see because this is typically the hardest part that we have here. But it'll take a little bit to create your copy of the environment and get everything ready to go. But once you have that ready, everything is up here and good to go. Last note with the GitHub repository that you have here, I do have the slides attached in here. The way that you can either clone the repository down yourself, or if you click on tplyr workshop.pptx, you can download the file directly from here so that you are able to have the slides that I'll be presenting available to you. So we've tried to make this information accessible. If you're having issues finding anything, go ahead and put that in the chat. Eli will be able to try to answer your questions for you, or if I see them and I can address them for you live, we'll be good to go. But if you get that set up, if you get in and you can get your projects created, then we're going to be good to go here. And that'll help us move right along as we go into the sections moving forward. All right, so let me throw this into. So to get started here, If you're unfamiliar and you haven't ever heard of tplyr before, tplyr is a package that we at Atorus released back in 2020 with the initial beta release and initially got the CRAN in 2020. So we invented tplyr to try to be a grammar of clinical summary tables. You'll probably notice that it's a shameless cop of dplyr for a package name, and that was intentional because dplyr as a grammar of data manipulation. We wanted to add or create a package that allowed you to add a grammar of summary tables from kind of the perspective of a clinical programmer to try to make that easy. And the principle here is that we wanted the design of tplyr to feel like you were describing the output itself. The way that we typically receive instructions from our statisticians to create a table is in the form of a mock. And so the mock will show what they want the output to look like. It could just be something in a Word document that shows what the structure of the table should look like when you prepare it. So we wanted the syntax of tplyr to follow that, to feel like you are describing the output that you're trying to create itself in the structure of it, and build up more of a specification to allow you to think about the data that you're presenting rather than as much about the algorithms to do things like formatting your strings, the algorithms to summarize the descriptive statistics, to do the counting necessary, to do your n's and percents, and to make that part simple and give it a set of instructions describing what needs to be produced rather than programming the output itself. But the other idea here was that we also wanted to stay in our lane, and we limited the scope of tplyr to producing an output presentation-ready data frame rather than doing all of the styling. So when it comes to how you present the table itself and you prepare the display, we wanted users to have whatever option they wanted of whatever library they prefer for styling, be that Flex Table, Huxtable, GT. There's a large suite of packages that can create really awesome tables out there. And that was not something that we wanted to try to compete with or to try to create another solution for. We wanted to leave that to awesome authors like Rich Ione for the package GT or David Hugh Jones for Huxtable and the great work that's been done out there as well. So when you're going through this today, just keep in mind in goes data, out goes a presentation ready data frame, and that is the scope of what we've done with tplyr itself. So why did we make tplyr? And I just gave you a sense of what we were intending to do with it. But the idea was that summary tables are highly repetitive, so code should be highly reusable. In the SaaS world, and the way that clinical tables are kind of dominantly done today, almost every organization has macros. But what we wanted to do was abstract away what was reasonably extremely repetitive and try to make that simple to do. So we broke it down to fundamental components of what are the typical things that you're going to do when you're creating a clinical summary table. And a lot of the data that we present is either going to be counting or doing descriptive statistics. And those are things that we could build some tools that would be easy to make it do well and to make it really easy to do those components robustly every time. So that was the scope of what we were really intending to solve, to create a flexible and modular framework to be able to describe these tables and produce the output. But the other principle was that text formatting of numbers can be very tedious. So coming from the SAS programming world and creating tables, you spend a lot more time formatting the numbers than you do deriving them. And that's counterintuitive and is a bit of a time suck and a waste. So we wanted to make the text formatting of numbers easy so that you can easily get to the presentation that the statistician is looking for without having to think about it too much. So you'll see as we go through, we built some tooling in to try to easily describe that and to easily provide what is present for you on your mock. So that you're not thinking as much about formatting, rounding, getting the numbers into the format for display that you're thinking. But then lastly, in the newest features that we've introduced that we're going to focus on through the work or later in the workshop today are how can we bridge into interactive tables and make that give more capability within the R environment itself to make your table more valuable. And the idea that we in a summary table, you have the summarized numbers and you can see and ask questions and understand more about your population, but how do you bridge that back to the actual data under the hood that's being summarized in the first place? So from the start of T-plier, we collected a lot of metadata around what data were being summarized in the first place, and what data were fed in to T-plier and what configurations were kept. We keep all of that information, so how can we make that more valuable to the user to feed back specific information about a result down at the level that's being presented in the table itself. So those are the three principles, or three core principles that were built in to why we tried to create T-plier and why we designed it the way that we did. So the newest features that we've added, if you've seen me talk about this before at other presentations and other industry conferences or past our pharma conferences, the latest updates in T-plier 1 are the traceability metadata framework that you're going to play with today. We also added reusable layer templates. So if you have a layer specification that is something that's going to be generic, you can declare that as a template so that you can reuse it on demand and try to make your code even more concise. Or if you have company standards around how you want to declare a certain type of layer, it lets you do that and access that more easily. In descriptive statistics, we have auto precision, like if you've done lab tables where you need to present the decimal precision as collected. So we also now added the ability to import that from external precision data that you might have to keep as a company standard that says that this lab test collected with this category should be presented to this level of decimal precision. Some organizations have that. Now you can feed that in separately. We added descriptive statistics as columns for when you want your descriptive stats across the headers instead of as rows to make that presentation a little bit more dynamic. You can now use our string formatting capabilities outside of T-plier tables, which you'll see a little bit today when you get into the F-string objects that we have. So you can use those format strings outside of T-plier in a context like dplyr mutate. And then we also added a new tool to do hyphenated string wrapping. If you need to specifically wrap your strings to a certain width so that that doesn't bleed in any other cells that you have, or if you have long running strings that go longer than the width and you need to insert the hyphenation, it's built on top of string R string wrap to try to keep the speed and the word breaking with that, but allows you to also hyphenate strings that are longer than the width that you have allotted, because some adverse events can get pretty long. So that gives some background and the motivation of the T-plier package itself. So to start here, what I want to go through are just the basics of T-plier to understand the concept and understand the structure. So it'll be stuff that if you've used T-plier before and if you programmed with it, you're going to be familiar with it. But for any users who are looking at it the first time, I just want to explain the structure itself. So the best metaphor that has been given to me for T-plier is to think of it as a cake. And I can thank Christina Fillmore for that. And it's a really apt metaphor. So I like this description a lot. But in a T-plier table, essentially each layer can have one or two basic flavors of what type of summary that you're performing. So the core layer types that we have are counts. So if you're doing ends, if you're doing percents, if you're summarizing some categorical variable, say sex, then that would be a count layer. And then the other would be for continuous variables, which would be like descriptive statistics, a variable like age, where you're going to do n, mean, standard deviation, so on and so forth of those of the different types of standard summaries that you'd present for a continuous variable. But with that core flavor, layers can then be decorated or have additional filling added. So to continue with the cake metaphor, what type of icing are you adding? What type of decoration are you attaching onto the cake itself? And that can be other attributes, such as what type of count are you presenting? Are they distinct counts? How is the styling of the n and percent going? What level of decimal precision do you want on your descriptive statistics? What statistics do you actually want to calculate? And what do you want to present on your on your table itself. So you have that decoration that you can add when you start attaching these tables together and stacking the layers up to the table. So the core components and the core objects within a T-plier table are going to be the outside T-plier table objects. So that's the conceptual table. And what that actually contains is all the logic necessary to construct and display the data. So it's your outer specification. So when you create a T-plier table, it's going to say, this is everything that I'm going to have to do to return the data frame that produces the display that you have asked for as the user. And then the tables are made up of themselves using tplyr label object or tplyr layer objects. And those layer objects contain the instruction for the specific summary that should be performed in that layer and all of the additional attributes that you want to attach into that to create and display the data as you want within that layer itself. So the table contains layers and a parent-child relationship and parent-child relationship, and those things come together to form the full specification of the tplyr table itself. So the way that you declare a tplyr table itself is to use the function tplyr table, and then that has a couple different parameters that you're going to provide. So that's going to be the target, and that's going to be the data frame that you want to summarize. If you're summarizing your demographics data, you're going to use ADSL from the ADAM standard. If you're summarizing adverse events, your target would be ADAE. So that's going to be the data frame input that you're going to provide into the tplyr table in the first place. The second parameter is going to be your treatment variable that describes what or the cohorts of the study that you're using itself. So in ADSL, this would be something like TRT1P, or in ADAE, your TRTA, for the treatment group that differentiates your subjects within the trial. You additionally, have the where parameter, which is going to be the filter logic that you might want to provide. So this would be if you want to do something like summarize your safety population. You would use the safety flag equals Y from ADAM in order to subset for that, or it could be your analysis flag, or it could be your efficacy flag, whatever subset that you want to provide to bring the subjects down into the population group that you want to examine. And then you additionally have calls, which could be other column variables that you want to incorporate as well. So let's say that you wanted to present by treatment group, and then within treatment group differentiate sex. You could provide the variable sex there, or it could be a list of variables supplied using the tplyr vars function to provide a list of additional variables. So with layers, we wanted all of this to have a very similar API. So there's 3 different types of layer of tplyr layers that you can create, and that's going to be count layers, shift layers, and descriptive statistics layers. All of these have the same API when you are declaring the layer itself in the functions group count, group shift, and group desk. So those are going to be the 3 functions, and the parameters for all of those are the same. So the parent is going to be the tplyr table itself. And we'll get to in a second how you attach layers to a table because we have a function for you to do that. There's going to be the target variable. So if you're summarizing sex, that would be sex. If you're summarizing shift, it could be ANRIND and BNRIND. So that you can declare the shift table that you want to perform to summarize the change in state. And then for descriptive statistics, it could be age in the target variable group there so that you can supply that. Just a note, we're not going to go through shift tables today, but shift tables are largely just an abstraction of counts that makes it easier to declare the change in state as you want to see it. So if you have BNRIND as your baseline, and then you want to show the shift to an analysis result at a time point, group shift makes it easier to do that sort of summary by declaring your from and your to variable. But for the additional variables on the group functions, you have by, and by allows you to introduce both character strings and additional grouping variables that you might want to present. So For the tables that you see here in group count and group desk, where you have those row labels that would say sex, n%, or age years, you can provide a string to by, and that will create a row label. But additionally, if you're creating something like a lab table, you can, within the vars function from tplyr, to provide a list of variables, you can specify a visit and param, and it will use those as grouping variables to summarize everything with those by groups. And strings and variable names can be combined there. And then additionally, there is a layer level where statement that allows you to subset the layer summary down to a further level beyond the table level statement, so that those two filters compound on each other for the data being summarized within that specific layer, which might be necessary for certain types of tables and certain types of combined results that you're trying to create. When you're creating and adding layers, we have the function add layer functions add layer and add layers to attach the layers into the table itself. So add layer, you can pipe in a tplyr table object. So add layer is specifically built to work with piping itself, and there's some extra aspects of that that we can, or that you'll see as we go through here. But add layer allows you to attach a layer specification. In the layer parameter here is going to be the group count function and whatever modifiers that you attach to it as well. And then lastly, you can provide a name argument to that if necessary, just so if you have any reason to extract out a layer by name, that's available. We're not going to use add layers today just because over the last 2 years, Eli and I have kind of idiomatically used add layer rather than add layers. But if you're using outside of a pipe context and you want to build up your layers as separate objects within your environment, add layers allows you to attach them all at once to the parent. But add layer singular is the typical way that you would produce a tplyr table, and it looks like this. So in here, when you create your tplyr table, we have to explain this table, and this would be the beginning of, say, a demographics table. What we have is that we're doing a tplyr table summarizing the ADSL data set. So you would use ADSL to do your demographics normally. We have the treatment variable here set as T or T01P. So that is going to specify how we differentiate the columns by treatment group. And then lastly, here we have the where parameter, which is going to say safety flag equals Y, so we can summarize the safety population. Using pipes, you can go into add layer, and then we'll say group count. And for here, we want to summarize age group 1. Note that in add layer, when you're declaring group count, you don't need to specify the parent because add layer is already telling you what the parent tplyr table is. So add layer, group count, and then we're going to summarize age group 1. And then in here, we have age categories in n%. And then to attach a second layer, we're going to pipe that into add layer, and we're going to do a descriptive statistics layer summarizing age, and we're going to present age by using the by row label of age years. When you view this tplyr table object, so just submitting that to the console, you'll get the print method associated with the tplyr table that tells you some information about the table itself. So we see that the target name is ADSL, which has 30 rows and 32 columns in it here. So we have the treatment variable, which is T or T01P. Some of this other information is not yet available because the table has not been built, but we have the where criteria of safety flag equals Y, and there are 2 layers attached to it as well. So if we move forward into processing the data, here we have just a single layer that was presented before, and we're binding that to T. So it's the same first layer that we have before. You can see that we have the number of layers as 1 in this table object that has been created. with the T-plier table presented here, the data are not yet summarized. So if you're familiar kind of with a lazy evaluation technique, T-plier is the specification that queues up what needs to be derived. And then here we're going to say, I want to get my data now. I want to see my data frame. And to do that, you use the build function. So taking the T-plier table object, you say build, and then it's going to go and derive that data. So the T object created here shows us the T-plier table print method, but build goes and summarizes the data as instructed by the table, and then we get out the actual data frame. When T-plier builds a data frame, there are going to be 3 core groups of function or of variable names that you'll see here, which are your row labels. So in this example here, by has age categories in n%, has been summarized on the left here. Age group 1 has been summarized as row label 2 to give us the less than 65, greater than 80, 65 to 80. Then the results are kept in the var1, or in the variables that start with var, with the treatment group name attached. So var1 underscore miracle high dose, low dose, and placebo. It has taken the TRT01 p-values and then added them into the column names itself. And then we have order variables in that help with sorting on the back end here to say that a word layer index is going to be the indicator for what layer you're in. So since this is the first layer attached, that's going to have a value of 1. And then generally, each row label gets a order variable as well. So we have ord layer 1 and ord layer 2. Ord layer 1 attached to the by value here, ord layer 2 attached to the age group 1 result. Just a little note here, you'll probably observe that this is not the correct sorting order for age group 1. Something that tplyr allows you to do is to provide factor variables that fix that sorting so that it will present in the right order. So if you declare variables or if you convert variables to factors and the factors have the correct order, and when you summarize the data, then tplyr will respect that for the sort order on the back end. And there are some other functions that can help you declare exactly how you want your results sorted as well. But I just want to point that out early because generally a feature of tplyr is that it respects factors for other things such as zero filling as well. So if there are factor levels that are not present in the data, it will backfill those and present the unavailable factor levels to zero fill those so that you can have the 0 rows if that's not present in your data itself. But the gist here, the main point to get across of processing the data is when you create your table, that is a specification of what needs to be produced, and build is what ultimately goes and presents that data and summarizes the data frame for you. So when you call it through build, you can bind that into a variable name to catch the data frame so that you can throw that into GT, Huxtable, Flex Table, whatever your presentation library of choice. And we're going to show in the shiny aspects of this how to use this with Reactable later in the presentation. So that's enough talking for right now. So what we're going to do is jump into breakout 1. So we kept this one on the simpler side, but let me explain a little bit how we have structured the breakout assignments for you to try to support you. Come on. To try to support you depending on what level of experience you're coming into the workshop ready to do. Our Studio Cloud generally, if it falls asleep, it takes a second to wake up. Once you're in here, it should be fine. All right. So the breakout sessions themselves are in these individual folders. So in the File Explorer down on the right, we are in Breakout 1. So what I'm going to want you to do is come into breakout 1 over here, and you're going to find 3 files. So what we've done, if you just want to see the answers and you just want to run the code and see what happens, you can use the underscore answers file here, and that has everything pre-completed for you ready to go. If you are ambitious and want to write everything yourself and try to do everything from scratch, we have the underscore blank files. So in here, it just has the problem of what you're supposed to do, and then just the basic variable names to bind to, and no helper there at all, just the instructions that I've given. And then if you want a little hand holding to see what's supposed to be done, but you type and fill in the answers based on the instructions, you can use the underscore helper file here as well. And generally what we have here is that if you see any spaces with underscores where underscores should not be, or some arrows that we have here, depending on the area, it is easier for me to supplement that. Then you fill in that area with your own syntax and run the code. So all of these files should be able to independently execute. So I put the library calls at the top of the file itself. Make sure that you run the code to read in the data at the top of the file. So for this assignment, ADSL needs to be loaded from the data that I have in the data directory. So that should be all pre-configured and ready to go, and for you to do the assignment. Read through the comments that are available in the breakouts as well, because I try to generally direct you to the documentation that'll help you complete the assignment. So the Get Started vignette from T-plier goes over the core concepts of what we talked about in the beginning intro section that I went over here. I have those links ready for you to follow. And then lastly, if you're not as involved with CDISC and you're not used to working with it, just keep in mind that we have a case-sensitive language here, and CDISC variables read from the original data as uppercase. So that gets really annoying if you're not used to doing it. For our programmers, kind of uppercase variable names are not the usual. I've tried to be consistent with that in the instructions, but I am a fallible human being. So just if you're confused, make sure that you're checking what the casing of the variable name should be. So let's give about 15 minutes or so to get through this first breakout. What I'm going to do is send you all into breakout rooms. Bring open the slides. Can everyone see my screen? Andrew, if you can just confirm since you're muted. Very good. All right, so that first breakout gave you an idea of just starting to create a T-plier table and understanding what happens when you create a table, what happens when you add layers to it, how you get the data frame out. So now we're going to talk a little bit about configuring tables. So in the last one, we baked the cake, and now we're going to do some decoration. So I did go over the T-plier table setting, and just to now expound on this a little bit as we go through. When you create the T-plier table, you have your target data set. So if you're doing demographics, you're taking ADSL, you have your treatment variable, you have that table level filter, so safety flag equals Y, and then you have your calls argument, so you can do columns by sex. And then all of those attributes are then passed down through the table. So if we have summarizing race, then race is going to be summarized by tier TO1P for your columns, and then additionally by sex, so that we see treatment group and sex. At that race level, we're going to summarize where safety flag equals Y. So that filter will be applied to the data. And then additionally, those same attributes are attached onto the desk layer that we create there when we're summarizing age. So that hierarchy happens. The layers are children of the parent, or the layers are all part of the same cake. So we're baking it much the same. So like you see here, we have the tplyr table. When you build it, we get that back out. So this is just to show you how those variable names are created and how that's presented. So when we build this, the columns that are set there have TRT1P. So we have the high dose, the low dose, and the placebo groups that have been summarized. And then similarly, you see that we have _F, _M for each of those variables to create the sex columns as well. So when you use that calls argument, you get the additional columns so that we can do that in addition to the by variables that we create there that are provided within the by parameter of the label. So we have those two types of grouping variables in actually 3 different sections, which is the treatment group, the additional columns that you want to summarize, and then whatever by parameters that you put on the individual layers. The layer ones are controlled at the layer level because those are presented as rows, which can be presented separately depending on the layer that you're applying. So you might be thinking, all right, so I have those treatment groups in my data, but then how do I add additional treatment groups if I want to summarize and look at treated, or if I want to look at a total group? We have 2 functions that are available to help you with that, and that's going to be add treat groups and then add total group. Add treat groups, you can provide named arguments and then supply a character vector of the treatment groups that you want to present. So here we're adding treatment groups and we're going to call it the treated group. And then we're going to say include the miracle high dose and the miracle low dose treatment groups into that will come together to make the treated group that we have available there. Additionally, you can add total group, and that will automatically create a total group for you. You can set a name so that it'll so that you can name it whatever you want for the treatment group itself, but it'll default to total, like you see down below. So over in here, we have the total group that's been provided, and over here we have the treated group. So with the treatment groups within your population, you're able to create that. You can create as many treatment groups as you need, depending on how complex your trial design is and what other what other combinations of treatment groups you might need to present. But add treat groups allows you to do that, and add total group allows you to add the total group itself. So additionally, with different types of tables, you might need to combine data from multiple sources. So let's say that you're creating an adverse event table. When you do your n's and percents of the adverse events, if you want to look at the number of subjects who experienced an adverse event, you're going to need to get that header n from someplace else, because ADAE only has records for subjects who experienced an adverse event in the first place, because that's how the events domain is designed in CDISC. So you won't know the number of subjects outside of ADAE itself. So we have 3 functions that allow you to set the population data for you. So set pop data, you'll provide the table. So the T-plier table, so you can pipe a T-plier table into this. So this is add treat groups and total group, and these functions are modifying the table object itself. So this is something that you would add before you get into the layer data, and before you call add layer. So if we just look at that here, I'm calling a T-plier table. These are your table modifiers that we can call them, and then you're adding your layer. But what's happening here is we have T-plier table summarizing ADAE and TRT by TRTA, and we have this filter statement to say where AE rel is not equal to none. So we only want to look at adverse events that were related to the study drug. So set pop data, we're going to say, okay, so my population data is coming from ADSL. Set pop treat var. So in this case, TRTA is the treatment variable in ADAE, but there is no TRTA that exists in ADSL for the data from the CDISC pilot, which we use for absolutely everything pretty much. But you have that circumstance where TRTA, you need to merge that back to TRT01A in the population data to merge the treatment groups properly. So we set the population treatment variable to TRT01A. and then we set the population where statement. Here we're setting it to true. So why is this? Well, in the table level data, when you're setting that where statement, we're saying that we only want adverse events related to the study. So AE-rel is not equal to none. Well, AE-rel doesn't exist in ADSL. By default, the table level where statement will pass into the population data, but set pop where allows you to override that because we would get an error otherwise saying that ADSL can't subset to a column that doesn't exist from that filter condition. So set pop treat where or set pop where is going to override the where statement, and by providing true, you're saying don't filter. So that is quite literally passed to a tplyr filter command, and if you filter true, it just returns the same data. So I see in the chat, you don't need to use all these functions together, only if it's relevant to your data. So if you declare a tplyr table, if you provide set pop data as ADSL, it will first assume that the treatment variable is the same as the target data set, but you use set pop treat var if your treatment variable is different than the target treatment variable. In this case, ADAE's treatment variable is different than what's available in ADSL, so we need to override that. If you don't need to override it, then you can just use set pop data. And then additionally, if you provide the where statement of AE-rel is not equal to none, then you only need to provide a where statement if you need to kind of bypass that table level filter. So let's say that the where statement was safety flag equals true. Well, safety flag exists both in ADAE and ADSL, so that will be fine. And then that will pass through. Fanny Kumar, you are exactly correct. If the big N is different than the dataset N, that's where you want to use this. Because in ADAE, let's say that not all subjects in the trial had an adverse event, some of them didn't have any, then you use ADSL to supplement and get that big N from the population data where you need to look back to get that. So ADA is a classic use case of that. And then additionally, if you ever need to get the header N from something else, or from the population data, because there are functions to get header ends in tplyr that we're not going to touch on as much today, but you can find that in the reference documentation. The population data will override what is inferred from the target data set. Okay, so we add our layer here and then we build the table. So just to restate, the target data set does not contain all subjects in the study population. Then you can use set pop data to get that. The population treatment variable is different from the treatment variable in the table level. You use set pop treat var to get that. And then if the population subset is different than the tplyr table subset, you use set pop where to get that. All right, so if we look into grouping variables, as I mentioned earlier, the by variables on the group count function allow you to set the grouping variables on the layer itself. So here we have an ADLB table. Let's say that we wanted to look at the reference range indicator in the reference range indicator for each visit and each parameter. So in here, the by variable, you're able to provide variable names as well. So you're going to use the tplyr vars statement. That might feel weird if you haven't worked with this type of data, or if you haven't done that in tplyr before, but what that allows you to do is provide a list of names. In here, by using vars, we can say, I want to group my data by param and a visit. And those two things will be combined together to produce the row labels that you see here, where we see the alanine aminotransferase test or parameter, and then end of treatment in week 12 as the visits that we're looking at the moment. And then this can be combined with strings to set character row labels as well. So that's just another thing to note there, that you can provide a mix. And inside the var statement, you can use strings, and tplyr understands that when you provide a string, that you're providing just a character row label that it's going to assign into the data, or take the values out of the variable name that you've provided in there as well. An interesting little tidbit about the way that bivariables are used to create sorting variables. Tplyr will automatically detect if in your input data you have a var_n version of the variable and will use that as the sorting number for it as well. So if you have param_n in your data, then tplyr will see that when you provide param_n exists, and then you're going to take that as an order variable. And the same thing for avisit and avisit_n. But if you don't have those and they're factor variables, it'll use that order. Otherwise, it'll use alphanumeric sorting. So just info, there is a vignette on sorting itself, because there's a lot of ways that people need to do that. So there's a lot of methods for working with that in the data. I had the duplicate slide. All right, so another note, if you want to do nested counts, then tplyr can handle that for you as well. So let's say you're doing an adverse event table and you want to summarize the preferred term within the body system in a pretty standard adverse event table structure that you have here in group count. You can provide 2 target variables. And what that's going to do is summarize AED code within AE BODSys so that you have those header rows of the body system that are available here. And then you can see row label 2, it automatically did indenting for you, which you can control. And you can provide some instructions on how the indenting needs to work with that. But to get that sort of nested adverse event table, you provide 2 variables into the target variable, and that will work like that for the adverse event, so that when you build the table, it'll go and grab that. And this is where the row label and the order variables can get a little discombobulated, because we provide the outer layer would be considered AE BODSys, and the inner layer would be considered AED code in this circumstance. But those variables produce, you can get that nested adverse event structure. The count vignette goes through how this works in more detail. Right. And additionally, in descriptive statistics layers, if you want to summarize multiple variables within the descriptive statistics, you can use vars for that as well. And that's why we have var_1, because in descriptive statistics, you could do, say, baseline, eval, and then change, so that you can do that, those lab tables where you want to see the analysis value versus the baseline, and then look at the change information as well. So for Fanny Kumar, for your question, in this table, there's some additional modifier functions that will say there's set. You can control the nesting to say set nest count equals true. We'll just drop row label 1 for you and rename your row labels for you, so that you just see that header of gastrointestinal disorders and then the decodes before it, so it tosses out that row label 1 column. And then if you want to do that, don't show repeating values, there's a post-processing function called apply row masks that you'll see in some of the programs later that we have queued up for, in some of the programs that we have in the Shiny app with some pre-built tables that have some of the post-processing for you. There's a vignette called producing styled tables that shows a little bit more in the post-processing world to make the data frame a little prettier before you get it submitted. So for controlling display, one of the things that I mentioned was the string formatting, and how this is something that we put a lot of thought into tplyr for how it's handled. So for controlling display with format strings for count layers, let's say that you want to do an adverse event table that's showing the number of subjects who had an adverse event, the proportion of subjects within the study population within their subgroup who had that adverse event, so the percent related to your header n, and then the number of events itself. So you've probably seen an adverse event table like this. Well, for count layers, you have these three formatable values, and then additionally you have totals as formatable values as well. But if you wanted to do that format, then we're going to use this function called set format strings. And in set format strings, you're going to use another function that called fstring. So what fstring does is it allows you to declare a format string that you're going to present. So in here, we declare the count layer, and then we're going to pipe that into set format strings, and we're going to provide the parameters that are, this is how I want my string to look. So that's going to be used by these x's here, and then we're going to say fill those x's with these variables. So we tried to make this so that once you understand the structure, that it feels relatively intuitive, to say that I want my string to look like a count here, then a count with 1 decimal place here, %, and then in here, the event count. So then you say, fill the x's with these spaces. So you have distinct n that goes in the first spot, distinct % that goes in the second spot, and then n that goes in the last spot. So since we're using distinct counts, the other note just to provide here is that if you're going to say I need distinct counts, you need to say what you want distinct counts by. So it'll yell at you if you don't do this, but we're saying present distinct n and then set distinct by uSubjID so that I'm presenting by subject. And then you can see down here that the display is updated to reflect that. So the way that the x's work is that the x's tell you what the width of that spot should be when you're looking at the integer. And then when you're looking at decimal places, it tells you what the decimal precision should be. So we have xx and xx.x %. So you can see here that we have auto-filled so that the integer width here should be 2 characters. And then we should have 2 characters in the % after the parenthesis and then 1 decimal place. And then additionally, here for the events, there's another little thing we did here that if you provide 1x for an integer width, it's going to expand to the length of the integer width so that the brackets here are going to hug the number itself. But the concept being that by providing the string of x's, you're saying this is what I want my string to look like, and then tplyr does the automatic padding for you so that you can align things the way that you want. To handle to get the number to display. If you dig into the vignettes, in the descriptive statistics vignettes, there's a lot about auto precision, which will work with information or the data as collected, or if you provide external precision, so that this can be dynamic. But just to note here that for if you're doing it manually, you have the x's as the auto format for that. So that's for counts, so that you can control how the counts are presented themselves. If we're using distinct counts, so to go back, the number in parentheses, so the format that's going on here is that you have the distinct. This is the number of subjects. Distinct n is going to be distinct by number of subjects. Distinct % is going to be the % of subjects within the treatment group. So using the header n value there, and then this n is going to be the number of adverse events that happened here. So the non-distinct count. So this is saying that and the n here is going to be the number of occurrences of application site dermatitis, or the events there itself. Now here, when we use population data, you can see how the percentages are changing between this. So you can see this in the 15 right down here, that when we add the population data, it's changed the available header n, and thus the counts, or the % has decreased, because now we're using the total number of subjects in the high dose subgroup instead of the number of subjects in ADAE within the high dose subgroup. So that to explain that's how the population data overrides. When it's present, distinct counts are going to look to the population data for those header ends and replace that for the use of a denominator. When we get into descriptive statistics layers, so we have a simple ADLB T-plier table here that's summarizing A eval by A visit and param code. So you'll notice that by default, we have these statistics that are presented with N, mean and standard deviation on the same line, median, Q1, Q3 on the same line, min-max on the same line, missing. The way that descriptive statistics works with set format strings to try to keep a relatively consistent interface is going to be that for here, what you're going to do is provide in set format strings named arguments, which you can provide in quotes, and then the F string configuration for how you want that row label to present. So this is trying to explicitly allow you to say, this is how I want my descriptive statistics grouped and presented on the table itself. So set format strings saying, all right, so present mean, and then I'm going to say mean should be presented with an integer width of 2, 1 decimal place, and then mean. Standard deviation on a number on another row, and then set the F string here, and I want 2 decimal places for that, and then add standard deviation. And then Q1, median, and Q3 all on one line, so that we have the F string call and saying that we want those 3 values presented, and we want the string to look like this, and then fill that with Q1, median, and Q3. So you can see here that now we have 3 rows for the Billy parameter. Our row labels are exactly what we put in the set format strings arguments, and then that's been filled with the strings as we described them here in the F string. So we have, you see those rows and how that changed. So this is the default, and then set format strings allows you to override the summaries that are actually being performed within that space. So just to flip back and forth, we have all of these summaries that have been performed, and now we've said, I want to just present these, and this is what I want it to look like. So you have that explicit control as a user. So you can see how we tried to keep the API relatively similar, just the different functionality requires some different settings for how that's declared, so they work a little bit differently. But between all layers, when you want to control the presentation, you use set format strings, and that updates as appropriate. And the F string and set format strings documentation explain in a lot of detail how all these things work. So the open question might be, where do these names come from that we're specifying? It's in the documentation there, but for count layers, your formatable values are going to be n% in total, which are non-distinct counts, so what occurs in the data, and then distinct n, distinct percent, and distinct total, which will update depending on your distinct by and be impacted by your population data for the header ends. Distinct total, when you use a population data and set or when you use the population data, is going to be your header n. So if you need to format and include your header n somewhere in the data, then a format string using distinct total will show what that header n itself is. For shift layers, you just have n% in total, but that behaves the same way as count layers. In the descriptive statistics, the built-in summaries that we have available are n, mean, standard deviation, median, var, which there's an open issue in the documentation where the name is var, but it's misprinted as variance. And then min, max, interquartile range, Q1, Q3, and missing. In the descriptive statistics vignette, it shows you the actual functions that sit behind the scene, because we do things like specify na.rm equals true for you, so that it automatically ignores NAs, but you can see the actual function declarations. Another note is that for descriptive statistics, you can add custom summaries to expand the available statistics that we have here. So you can make your own function, you can give it a name, and then that becomes a formatable value. The criteria is just that it needs to behave like the median function, for example, or like the mean function, where it takes in a vector and it returns a value, and so that can be run on groupings. And then again, the function definitions in the descriptive statistics vignette are there available for you to see how it's actually calculated. And so this case, var is variance. Thank you, Andrew, for answering that. So that brings us into breakout 2. So we'll hop back over into our Studio Cloud. So this is going to be a slight expansion off of breakout 1, where you're going to do some of the table configuration. Go ahead and wake up our Studio Cloud instances that you got going on there. And then again, we have the answer key, we have the blank files and the helper files. So we have a couple different assignments to go into here, where we're going to add a couple extra modifiers on and work with some of the different formatting capability that we have here. So this is relatively short. Let's keep this one to about 10 minutes. We're going to send everyone back to the breakout rooms, and again, we'll be hopping around to help you all out as we go through this. All righty. So now we're going to get into the meat of what we wanted to do this workshop for, which was to introduce tplyer's metadata. So admittedly, this will get a little more dense in this section, but I'm going to explain how things work, what the concept is, and the objects that we've made available in this, so that you have a fundamental understanding of what the metadata is. Because in principle, what we've tried to do here is to actually really minimize, from a Shiny developer perspective, when using tplyr, how much actually has to go into the Shiny side itself. So this is really the core part of what makes tplyr interactive, and gives you that interactive capability to let the client and the server talk when you're using that, when you're building a tplyr table. So in this section, we'll go through the meat of tplyer's metadata, how that works, and what it actually means. So in the design of tplyr, as I mentioned in the beginning, what we tried to do was capture information about your specification, what you were producing. So when we look at this table, I know that there are 3 layers that are being presented, where we're summarizing age group, we're summarizing age, we're summarizing race, all as different variables. I know that I have my treatment groups that give me placebo, the low dose and the high dose group, and that comes together to produce the table. But when we produce summary tables and we interact, when you see a count on that table or you see some number, then you're the natural next question, and you probably, as a stat programmer, gotten questions from your statisticians to go and say, who are the subjects that produced this result of 6 subjects who are Black or African American? So who are the 6 subjects in the low dose group who are Black or African American? Or furthermore, if you're looking at the high dose group and you see a number in the median here, say that the mean and the median were far off from each other, so you want to see what the outliers might be in that group that stretch that data point separately. So who are the subjects in the high dose group so that are producing this median of 76? So the question is, what data from my input produced that result itself? When the data were summarized, what are the actual data that are feeding in to summarize and produce that median of 76, or produce that count of 6 subjects? So when we say metadata, and I tried to update the language around this a little bit to say traceability metadata, because really what we're trying to answer with that question are the 2 questions of what variables from my input data set were necessary to derive the result. So all your grouping variables, all of the column variables, the row grouping variables, any of the filter conditions and the variables applied to the filter that were necessary, and then ultimately the target variable itself that is being summarized. So that so what variables were necessary, and then the filter conditions themselves. So ANL01FL equals Y, or safety flag equals Y, or whatever other filters that have been applied to actually produce that result. So that is what metadata means in this context. It's not necessarily saying that this is table 14301. It's not that other type of metadata that we can apply. Metadata in this context is what data were necessary to produce the result that I see on my screen. And that is trying to take when you're looking at your data frame, that big square picture of saying all your rows and all your columns, filtering it down to just the necessary variables and just the necessary filters to get you down from a height and width perspective to produce that smaller square segment of your data that was actually led to the derivation of the result itself. So when you produce a T-plier table, so in here we have a small example of building a T-plier table for ADSL, summarized by treatment group, and then we have 3 layers, just like the result that we had on the screen before, of saying we're going to summarize age group, we're going to summarize age, and we're going to summarize race. When I mentioned that this is supposed to be easy from a Shiny developer perspective, if you want to get the metadata back and you want to enable this to be available, there's one new argument that we added to the build function, which is metadata equals true. And then that's going to go, it's going to build your result, and it's going to build the table exactly as you had it, but in the background, it's going to organize the metadata for you. The parameters there is an option because it does take some extra processing in order to do that and assemble everything. So if you don't need it, you can turn it, or you can just leave it with the normal build function. And then in the background, nothing is extra assembled, but when you turn on true, it's going to make the objects that I'm about to show you in here present for you so that you have that available. It's not a massive amount of overhead, but if you can avoid overhead, it's nice to be able to avoid it. But when you use metadata equals true, there's a new column that's introduced for you called row ID. So row ID is going to essentially be used as a connector to go back and forth between the metadata as we see when we're going forward into the other slides. So build metadata equals true, and then what we get here on the right is going to be the same data frame from before with the row ID column attached as the leftmost column. So why is this necessary? Because the way that the metadata exists in tplyr is going to be an interaction between the output data frame that you get from build, and then that's going to talk to a tibble that we have inside, so a data frame that lives inside the tplyr table object. That's the metadata data frame. So the way that this actually talks to each other is by the tplyr metadata data frame here is a lookup table, essentially. So on the left, we have the output data frame, and let's say that we're looking at row ID C2_3, and then in the column placebo. That is going to be kind of the keys that are necessary to find the metadata object associated with that result cell. So why does it do it this way? Because when you produce a data frame out of tplyr, it's a data frame that lives on its own after it leaves the table itself. So its output, the results are generated, and then you can sort it, you can massage it, depending on what table library that you're using. There might be other styling and modification that needs to happen to that so that it's ready for whatever output that you're actually producing. Or it goes into some other type of table library, like GT can do stub headers, which isn't something that necessarily pops out of tplyr's data frame itself when you are summarizing the results. So there's a lot of different stuff that can happen, but we wanted a persistent capability to say that here's the originating row identifier and then the column that was output by tplyr to produce the result that you have itself, or that you want to look up. So the row ID gives you tells you what originating row we need to find in the metadata table, and then the column gives us the lookup to find the tplyr meta object that is associated with that result itself. So get meta result is a new function that we've introduced to allow you to do that talking. So if we go back to this picture, we have these things, or the row ID, we have the column, and we want to get back the tplyr meta object. Well, I didn't want you to have to think about that much. Just an understanding the structure of to look at what result you're trying to pinpoint on your table itself. You have here get meta result, which takes in the tplyr table object. Now note this is the tplyr table object. It might seem weird to you as an outside developer that we have this tplyr table object, that's the specification, but this is really why. Build returns a data frame. That data frame doesn't have all of the information that was existing in the tplyr table object, it's just a data frame itself. And when you put data frames through other functions like dplyrs functions, you have no control over if you're losing attributes or other things like that. So a tplyr table as an object exists out on its own. It exists out on its own to hold that metadata and be the container of all of the originating information. So you have the tplyr table object, you built your result, you have that data frame, you're presenting that data frame however you want to, and then get meta result to extract an individual tplyr meta object. Let me make sure I turn on do not disturb, sorry. So get meta result extracts the tplyr meta object that's going to contain the metadata associated with that originating result. So we have the row ID of C2_3, we have the column name of placebo, and what that's going to do here is this is the print method associated with the tplyr meta object. So it's going to tell us we have 2 names and we have 4 filters that are attached here. So in names, we have TRT01P as my treatment variable from the table before. So you can see back on the code, we have tplyr table, ADSL, and TRT01P. And then race is the variable that's being summarized. So we have race is another variable name that's included in here. So it's the placebo column. So the filters are going to tell us that the filter condition for this is TRT01P equals placebo. And then we also have for C2_3, this is the Black or African American subjects. So we have race of Black or African American from the input data itself. Now you'll notice here that we have 2 parameters here that are true. Just to explain that quickly, why that exists is that the default where statement for the tplyr table function is going to be true. If there's no filter applied, we filter true, which gives you all records and just doesn't do any filtering. But that lets us bypass that without writing extra conditions. And then for the same thing for the layer level where. So since we did not use that parameter for either where statement, you're going to get true and true for the input data that we have available there. So the tplyr meta object gives us that information, but that might not be exactly what you're interacting with when you want to work with this yourself. So if you want to extract the metadata and get the subset of that data to go directly back to the source and say, I want to grab this from the target and give me that smaller square of the data that I want to look at, get meta subset has the same exact API that we have available there, and then it's going to go and carry out the select and filter statements necessary using the tplyr meta information. So what this is saying is give me TRT01P and race and subset to where TRT01P equals placebo and race equals Black or African American. And that's what we got back here. Get meta subset has the add calls parameter so that you can also add additional variables to the selection if you want to see more than what was available in the tplyr meta object itself. So it adds that additionally. It defaults to uSubjID because most of the time your question is going to be looking at who are the subjects that I'm interested in here. So let me see that data. But you could also say if you're looking at adverse events and you wanted to get that back from the metadata subset, you might look at treatment or at the start time to end time or other information beyond what was actually used in the summary if you want to get that subset back. So as a developer, you have that control, depending on the context, to add the other information as necessary to the subset conditions. All right. So again, what the basic interaction that's happening here is that your T-plier table built, and you have all of the results that have been summarized for you. But then the next question is going to be, all right, I look at my result and I want to see the input data. You have that square that has been taken from large to small of all of the data down to the relevant subset of data to trim off the columns that aren't relevant to the data point that you're looking at and trim off the rows that aren't relevant, so that you have that input that when you put it through whatever summary function, it gives you that number that you see on your screen. The thing is that tplyr doesn't do every summary that you're going to need to perform. So that has limited value in that if you can click some cells and get the result back, then that's cool. But if there's other cells that you see a result and you can't get the same investigation, then how can that be, or then that diminishes the use a little bit. So you can, all of these methods have been externalized as well, meaning that you were able to create your own metadata objects. You're able to create and modify them and interact with the metadata itself as needed. So to create a metadata object yourself, we have the function tplyr meta, which allows you to create and instantiate a metadata object. So this would be for a single result. Sorry. This would be for a single result. So a single metadata object is supposed to associate with a single result on your screen. And then add variables can expand that. So if you're trying to do this dynamically, of course, you can just add the names and the filters into the tplyr meta object. And in the next slide, I show you how to create these objects, but you can expand an existing metadata object that you've created to add variables to it. You can add additional filters to it, and this works with piping syntax. And then, so you have those capability to add and update existing metadata objects that you've created by yourself. Additionally, and you'll see as I go through and in breakout 3, what you ultimately want to do for this is to create that metadata data frame or expand that metadata data frame that sits behind tplyr. So going back here, let's say that you're creating your own set of metadata as a lookup table. What you need is to have a row ID and you need to have the columns available, but then you look this up from within the data frame. So if you want to expand an existing tplyr table, we have the append metadata function, which will do a bind rows action or a set operation to expand the metadata that sits inside tplyr so that you can contribute your own and expand it so that your output result table can still talk with the tplyr table object using get meta result and get meta subset. And then additionally, the function get metadata will pull out the metadata data frame from tplyr, from a tplyr table itself, so that you can use this outside of tplyr completely, or pull out tplyr's metadata to work with it outside of a tplyr table. On that note, get meta subset and get meta result are both S3 methods. So if you use it with a what you can provide to it is the target data frame. That's the input that you're subsetting. And additionally, the metadata lookup table that you need to talk with and use these outside of a tplyr table context. So they have S3 methods that will work with data frames as well. And the documentation states the where you put those arguments. Today, we're going to use them with the tplyr table, so we won't use the data frame S3 methods. So that's a lot to take in, but let's look at a little bit of how this works itself. If you're creating custom metadata, then we have this process of how you can create and expand an existing tplyr meta object. So the core parameters that we have here are going to be tplyr meta. And then when you're creating that object initially, it has 2 arguments, which are going to be names and filters. The way that you can provide these names and these conditions is to use the close function that comes from rlang. But close to do TRTA, aval, param code, and avisit, and that sets the names that are available in there. And then filters will provide safety flag equals Y and analysis flag equals Y to set that condition for a individual tplyr meta object. If you're unfamiliar with closures, the metaprogramming chapter or section of Advanced R goes over what closures are. These could be expressions, but admittedly, closures are a lazy way that you can provide names or expressions like the filter conditions themselves. It's a dense topic because metaprogramming itself is a kind of challenging topic, but when you're thinking within the tplyr meta context, all you need to think is that what are the names that I need to provide, and then in the close argument or the close function, you can provide that list of names, and then in filters, you can provide the syntax for the filter conditions that you'd want to add into that meta object. So if you want to expand the object itself, the way that you can do this is to add is to pipe and then add filters. So we're going to create another metadata object. So this is a separate metadata object that's just building off of the first one that we created to say that I want to add the filters for TRTP in, and this is a bad example for me because I'm in here specifying TRTP, but I don't have TRTA there. So typo on my slide, but that's fine. The examples work. So meta, we're adding filters to say, add another condition where TRTP is one of the values of high dose or placebo. We're creating another object separately building off of meta where we have low dose and placebo in TRTP. And then the last one where we have high dose and low dose. So this is built off the example that we're going to do in breakout 3. But again, what we're doing here is essentially saying, all right, I have that core object that has most of the information that I need, but what I actually need are these separate ones. And what we're doing here is building up the subsets that are relevant to contrasts of when we're comparing different groups. So on the table, we have 3 different contrasts that we want to show. All of the information of TRTA, aval, param code, avisit, and then the safety flag and the analysis flag filters are important to what I'm doing here. But for the separate groups that I have in my table, I'm going to want to show high dose versus placebo, low dose versus placebo, and then high dose versus low dose for the efficacy summary that I'm providing here. So I make these 3 objects on here, and then I'm ready to go. So how does that then get into a metadata data frame? So when you create custom metadata, you can build up your tibble or your data frame that's actually going to present that result itself. So this is what that ends up looking like when you put it into the data. So in the examples here that we have today, I built this up just using Tribble because I know what my data look like. I take that and then just to show what I'm going to do is build this data frame that has a row ID on it. And then I have the low dose and the high dose groups as my columns that are being presented. I have set all my row labels the way that I want them, mostly for a sanity check there. But then you can insert the metadata objects in the proper location to align with the row ID and the column name that you need. The important part of any of these data frames when you're building the lookup table is just that the row ID and the column together, that cell has the proper metadata object. There's a lot of ways to do that. You could build it with case whens, you could do it dynamically based on your data, or you can manually specify it like this. And the reason that I chose this way to present it is it's explicit and it shows you what's trying to happen. So here, I'm just establishing those row IDs and putting the metadata objects that I created where they need to be so that the proper variable summary, or so that the proper subset is present on the cell that you're going to click for that. So the metadata objects, when you put it into a data frame, are held within a list column. So going back to the object types, data frames in R have that extra benefit of being able to hold a list column where you can put any type of object needed inside it. So when you insert a tplyr meta object into a data frame, it's going to need to be a list column. You don't need to declare anything for that. When you assign that variable in, the data frame is going to convert its type and store it as a list. So you need to insert the metadata objects into the data frame, add appropriate locations to match with the results. The idea there is always going to be the two keys that you have, the row ID and the column name, and that when you select out that cell, that's how you get to the metadata object as necessary. And then lastly, the row labels aren't strictly necessary. You just need the row ID and the proper column that matches with the results, and then you're good to go. I include the row ID here so that when you're trying to understand and look between the two objects, that you understand those two things together and can see the traceability between the two of them. Once that metadata are created, and once you have that available, then append metadata will attach that function into a tplyr table. So the syntax is just like you see here. You have your table object, and then you have the data frame that you want to bind to the internal tplyr table object. So using that together, we'll attach the metadata to the existing metadata data frame and the tplyr table. And then again, alternatively, you can extract this metadata data frame outside of tplyr and use the S3 methods for that. But that's not what the examples are going to use here today. And append metadata when you're working with a tplyr table will allow you to specify that how it needs to be specified. So that was likely a lot to take in because this is one of the more advanced topics within tplyr. But what we're going to do now is get you into breakout 3 so that you can work on generating, extracting, and extending the tplyr metadata object. So let me pop this up and resume. All right, so we're back in there, back out of breakout 2, breakout 3, and I'll hop into helper file. So we have the data that you're importing here, and then do note that there are vignettes written on this topic that go over what I talked about and walk through instructions. So I encourage you to open up the package sound site and jump in to try to understand this. The first vignette goes over the basic concept. The second vignette goes over the custom extensions of everything that we added in here. So in this breakout, you're going to walk through creating a table with the metadata and getting the metadata back out of it. You're going to investigate that a little bit to see how you can extract out the metadata or the tplyr meta object, and you can examine that and look at the object itself. You're going to get the subset data frame. So just note that in problem 5, there's some code here that you're going to have to run so that you can understand problem 5 itself and problem 6. Just go through, make sure that you complete this. This is actually an example from building off of everything that we did previously of using tplyr in an actual real world example. So this code came from reproducing the primary efficacy table in the CDISC pilot for table 14.301. So it has tplyr producing the entire header portion and then mocking up the results from the rest of it to produce that table. So doing a little bit of a cop out here and building that data, but we do have the modeling code necessary for that for reference if you want to see from the R consortium submission pilot, grabbing those results And then once that's ready, you're going to build up the metadata objects, just like in the last example that we went over to produce everything down below. And then combine it together and look at the metadata from the T-plier table. So for this one, we're at 11:21. I'm actually going to give, let's do about 35 minutes for this, because let's build in a break. We've been at it for over 2 hours now. And I know I need a little bit of a break here because of talking. I don't know how Phil does this constantly when he goes out and gives workshop after workshop during the week. I know
Coffee.
that green tea and honey are a key part for you. Yeah.
Coffee now. Green tea's too healthy.
I drink plenty of coffee. That's my team. I have these 24-ounce giant mugs
There you
here
go.
all the time. But so we'll do an extended breakout here. I'll actually set a timer this time. But so this is really the bulk of what we got to go over today. So take your time and just explore this. And we'll hop around to try to answer questions for you. I did try to do a good job writing the vignettes, so I hope that those also help you as well as a follow-up from this. But this is the crux of it. So this is the crux of the drill down capability. And then in the next sections, you'll see how once you get this and then you make it into Shiny, there's not as much work that you have to do after. So tplyr's metadata capability is a backend tool to make it easy when you're trying to do the display itself. So we'll see that in the next 2 sections after this. And actually the lecture portion after this is much shorter because we'll get into the Shiny portions for breakout 4 and 5. But I'll throw you into the breakout rooms now. We'll start hopping around, but also you can take time during this one to step out, grab yourself a snack. For those of you over in Europe, in Asia, some dinner perhaps, but I'll open the rooms now and we'll do 35 minutes for this one. So thank you all, and let's hop in.
I have a suggestion. I think it's worth mentioning, again, the issue that we just talked about, how there's the meta subsetting is supposed to work at this cell level.
Yep, I have 2 points that I want to
Nice.
go over from those breakout chats. All right, the rooms are all closed. Welcome back, everyone. All right. I have some stuff that was talked about during the breakouts that I want to go over. All right, so let's say that I have my table. I build my table, I get my result. One of the first questions was using these functions for inline statements or doing other things within your programming. So talking about the functionality, we're steering into Shiny today, but just keep in mind that these aren't Shiny functions. These aren't anything for explicit Shiny programming. These are R functions and work with data at the programming level. So whether I'm exploring things myself, whether I'm doing programming in my day-to-day, or if I'm trying to build some other automated application for something like a R Markdown or Quarto document, when I run this get meta subset function and produce that data frame, what is subdata that comes back to me? It's just a tibble. So what it returns to you is a tibble of those results, and I can explore that here in my data viewer, which means that now I have data in my session that I can work with. So it could be something that you create a plot. It could be something that you explore the data frame. You can grab the from that result the subject names that come out of that, and then you can say, I'm going to very badly do a for loop, but just to, we're X and what am I doing wrong here? So I can iterate and I can take action and say, now that I have these subject names, maybe make a patient profile for the associated subjects from the set of subjects that I'm looking at. So inline statements, programming, working with this in any context, what you get from get meta subset is going to be a data frame. And you do with that data frame whatever you can dream of programming itself. So whether it's inline programming, whether it's exploration, whether it's using it for some sort of other automation, that data is exchanged to you and from the records that are pulled out based on the metadata provided. So that was just one question. This isn't what these ultimately become are just tools talking in the back end of the server. And the next section that we're going to go into is about exchanging data from the UI to get you into the server so that you can pull out the cell coordinates, which are the row ID and the column name. So that was a good point that I wanted to show everyone. So thank you, Fanny, for that question. And Fanny also found another little I actually filed it as an issue so that we can update it within tplyr for whatever next patch release that we put out there. But one of the things that Fanny was trying to do is say you wanted to try to look at additional column names here. Well, when using get meta result or get meta subset, if you add in the column name, but then you do a comma and another column name, what actually happens is not what you'd necessarily expect to happen, is that it kind of silently returns the same thing. So I can kind of just show you here. That identically what's returned are the same issues there, and that was overkill just to show you explicitly that those two things are equal. But what he was expecting to happen was the combination of the two results that you have that are returned from there, so that you get the subjects that were in the column var1 placebo and var1 high dose in there. So you can do it with two separate calls to get meta subset to get the subset results there and return that, and combine data frames that have been returned from looking at multiple columns. But that's this is silently not yelling at you because essentially with the S3 method, I just kind of ignore. Well, in get meta subset, that doesn't work because it falls into the other parameter category. But just a note on that, this tried to use a parameter that wasn't there, and bad thing, or it silently didn't message anything, which is not what I want. So now issue 102 in tplyr is marking that we're going to fix that in the future. But if you come across anything like that, we love to hear things that are not happening as expected so that we can try to fix that and really embrace that feedback. So thank you to Fanny for that feedback. And those are two outcomes from the breakout session that we wanted to address with you all. So I hope that breakout 3 got you exploring and understanding the data that we're playing with, understanding a little bit of the communication, because this next lecture section, which is going to be shorter, is talking about where you go from here. Now that you see that you have this tool that's talking between the data that were summarized and the results that were produced, and then talking with the tplyr table object to generate that metadata, how you can extract it, pull it out. You looked at a little bit of how you can create the tplyr meta objects and expand them and create your own metadata that says that these are the sources that were important to the summary that I performed. In a more, if you were building your own applications, you could use those tools to more dynamically produce that metadata for your own summaries if you can produce that, and if you have an application that can consistently do that, because that's what we do in the back end of tplyr, assembling all of that. We use the same functions that you were playing with to create the tplyr meta objects to then derive the results based on the summaries that are produced by tplyr and everything in there. So you would be able to do your own automation of custom functions that you create to expand tplyr's metadata, but you can also manually specify that when you are confident in the assignment. And that's what problem 5 and 6 were showing you of the last breakout. So now let's think about how this works with Shiny. So this is a really basic schema of the communication pathway that is supposed to be happening here when you're working with the Shiny application. So you have that tplyr table, the tplyr table object, and that tplyr table object produces you the summary data frame, and you do whatever styling, you do whatever post-processing that's necessary on that, and then that can pop into an interactive table. So the tplyr table also produces tplyr table metadata, and that's what we were working with in the last section. So now you guys have a good fundamental understanding of what these objects are, how they work, and what is, and the products that come out of this. So the next step when you work in a Shiny application is that you have that interactive table that's existing in the UI that's presented, it's returned and rendered by the server and put on your screen, and you have that to interact with. Well, what happens there within the Shiny application is that let's say that you have the capability to do an on-click event. So the purpose of having the row ID, the purpose of having the column information in the table that's been presented is that in that click event, you guys worked with get meta subset and get meta result, and you saw that you need two pieces of information, which are the row ID and the column. And I keep emphasizing that because what the information that you want to gather from the click event are those two parameters. So with those two parameters, if you can extract that from the UI, what you can do is send that back to the server, or send that back to the server as an input binding in Shiny. So with the click event, you say, all right, the user clicked row ID at whatever and column whatever, and then send that back to the table metadata. With that information, you calling get meta result or get meta subset to get the data frame, you can then have a reactive element that grabs that relevant subset and then returns it back to the Shiny application. So what does this allow you to do? You've now seen the framework of how manually you can pass that information, but how do you take that forward a little bit into to work in the context of a Shiny application so that you have a user interface and some sort of action that the user can take to dynamically provide that information. And the benefit of working with reactivity is that as that click event's updated and you get new information, well, then now you can start talking with the server-side functions that can dynamically return this information for you. And then there's other considerations that I just want to emphasize, which is note that get meta sub the tplyr metadata, now that you guys have explored that, at no point am I storing the subset data. In the current design of tplyr, you're not carrying around these heavy subsets of data. That tplyr metadata is not actually looking in a lookup table to find all these pre-specified subsets of data. By using metaprogramming and using the capabilities that we have in R, I'm saying, here's the information that you need, and get meta subset is actually going back to the source data and returning the filtered data to you on demand. So from a performance perspective, what's happening here is not carrying around a ton of memory and making a really heavy application. What you're doing is you click, that reactive element says this input binding has updated, create a new filter, render the table on demand. So you can quickly, and you'll see that this is relatively performant as we go through because you're taking information and then returning the subsets and doing the filter on demand. So this is the general idea, and I hope that I'm working from the last assignment. You're starting to see exactly how this is supposed to work. How does it work in practice? On that click event, the demo that we have today is using Reactable. Why Reactable? Because it had this on-click capability that you can embed into the cells. And also, I didn't write this because Matthew Kumar, the first time that we dropped the first initial prototype of this, I presented it on like Friday, and on Monday he had an application that he sent over showing the capability. So all credit for what he's designed here goes to him, because I just stole components of it that he produced in an application that he stood up. Matthew Kumar is a computational biologist over at Bayer. And so this is what he put in there, and it works with the assignment that we did today. So talking about Reactable and the capabilities that Reactable has, in the on-click event, if you inject this little JavaScript function, it opens up the capability to talk with Shiny. So as you can see here, you're recognizing in JavaScript that you're in Shiny, and that the Shiny application is open when the table is being presented. So he's going to tell Shiny to set the input value of row to this small little JSON element that you have there, which is the key index, and then he's taking the row info in the index of that +1 to extract that out. And then the +1, because of the differences of indices in R vectors start at 1, JavaScript at 0. I think I'm not a JavaScript developer. I brought Andrew to answer more about that if necessary. Thank you. I think I've just done the typical 1+1 example where it gets confused with strings, and that's about the extent of what I've really coded in JavaScript. Not my forte. I wrote tplyr. The other one here to get the column, saying Shiny set input value and grabbing the call info information from the Reactable, setting the index element there to column, and that little JSON return value. So you're setting those input values into your Shiny application. So in the server side, you have the input output objects that are contained within Shiny, and you're binding that into those values so that they're accessible. For this to work, you need them as reactives, and reactives being able to monitor that and call them when they are updated in the server. So what we have here, the object b_tab, I more intuitively named it results for the application that we're going to have, but b_tab meaning the built table. So you're looking at the results that were generated in tplyr. And what he's doing here in the reactive is saying from input, grab the element row. So we set the input value to row. So that's how this is talking, set input value row. And then in the, this is sitting in the server. So we have input and row. And then from that, grab the element index. So we have that index here. I'm not an expert in this, but talking with Andrew yesterday, we did a little exploration of can you take out this returning a little JSON element so that we can just access an element within row without having to name it index, and it didn't work like that. So we think this is a Reactable specific thing, but this works, and this is what we're showing today. So we're grabbing index from there. So what that's going to do is here, return that information. We're going to grab out the first column, and then he's just getting at the row ID value within the data frame. So what is row doing? This little snippet here, and just digging through the nesting a little bit, is finding the row ID from the result table from the row index that we extracted. That's the gist of what's happening. So in the input value, we're just digging in, saying, here's what I'm looking at in the Reactable. Now go and grab that row ID from the results table that we're talking to right here. Okay. So from there, the column is a little bit more intuitive here. So call is talking to the input binding of call, the element named column, and the return element that we had there. And then call info.id, that's the value that we pull out, and that's the column name that sits inside the Reactable, which effectively gives us the column name of the data frame. So now we have a reactive for row, and we have a reactive for call. And those two things allow us to access the tplyr meta object. We have those two things that I've now talked from the UI. So this is the UI end of what we're discussing. And now we have a reactive element that is going to give us the row identifier and give us the column name from within the reactable that we're talking about. So I'm going to say that one more time. If you're not a Shiny developer like myself, then you probably need this kind of embedded a little bit. What we have here in the reactable is this click event with this little JavaScript snippet that allows us to go in, set an input binding to the row value, grab the index, and give us the row ID from the results data frame. That's everything that's going on here. Finding where we are in the reactable table, taking that information, pulling it out from our results data frame, and getting our row ID from the tplyr or from the built tplyr data frame. Doing the same thing for column, finding what we're looking at in there, and then grabbing that input column from the data frame, and then binding those to reactives. Binding them to reactives because you want this to update every time you click and then talk down to the server. All right. So how do you leverage that? Well, that is where we have this little function to create, well, we have this little reactive that we create. We're going to call it subdata because it's the subset data that we're examining. And then this is what you got to do on the server side. And this is why we tried to design it the way that we did. We pass that information now and we have those reactive elements. I threw it around rec just to require that those reactives are there. Otherwise, it bulks out of the sub or function. And then we have the function get meta subset. We have the table that we created. And so here, that's called tab. This is the same function that you were just working with. But with these reactive functions, we can call them. So if you're unfamiliar with the Shiny or you're vaguely familiar with Shiny, like myself, reactives are callables. So you're going to use the parentheses open and close. But we have row, we have call. We've taken that information that we've gotten from here. So everything that we just created in these reactive elements, and then we're going to call our reactives, grab it out, and then great. So get meta subset. That now has a data frame stored in temp, and we return temp from the reactive, and we're good. So you call the reactives and get meta subset to extract out the relevant data frame. And then the resulting data frame can then be rendered however necessary. So subdata, what that is going to then return as a reactive, meaning it'll update anytime that element in the chain of history relevant to that element is touched, that data frame will update. And then it is up to you, whatever you want to do with that. In the examples today, we're just going to present those results in another reactable. In the Shiny applications that we have queued up for you guys to work on, it's meant to be as simple as we can make it to demonstrate these concepts. But that's what we're going to do. So we're ready to move into the next breakout here, where you're going to now take some of the learnings that we've done here and make a Shiny app and breakout for. So if I come over here, and thankfully this is still awake, so that's great. I'm just gonna, oops. The breakout for this works a little different because these are meant to run as Shiny applications. Just a note, yesterday I had a little bit of an issue when I was running in RStudio Cloud where it was saying connection refused. If that happens to you, log out, log back in, restart your session. It eventually went away, so I'm just giving a heads up of that issue. But in the application that we're going to create here, what we have is this is a really basic T-plier table that was rendered using Reactable. You have the Reactable code here that you can look through it, try to do some minimal styling, try to do some minimal post-processing just to get the fundamental concept down here. But now with these click events, you're going to get that table back to you. So every time you're clicking one of these, it's talking back and forth and giving you that subset. And that's presenting back to you within the Reactable table. You can click around here and get all of the different information. So in the same style as the other breakouts, we have the helpers for you. So you'll complete the T-plier table and then make sure that you're building that with the metadata equals true. You're going to complete the reactive elements in here. You're going to complete the on-click event for the little JavaScript code that we've derived here. And then finally, the subdata reactive based off the information that we just did in the slides, and build your own little Shiny app here. So hopefully if you're trying to do the helpers, it's intuitive, and hopefully if using the blank, this was relatively intuitive here. And this was a little bit harder to create the blank exercise for you to do yourself. But go ahead and work on that breakout. If you're unfamiliar with using Shiny, the Shiny app to run everything, you're going to click Run App, and it'll bring up the pop-up window. If your browser is not going to let the pop-up windows, that's going to fight with you a little bit, but you're just going to need to allow pop-ups on this site. But otherwise, everything like that should follow the same structure, and this will get you in and working with this in a Shiny context a little bit, so that we have that to do. We're running down to the last half hour here, so I'm going to give you 10 minutes on this one because there's not as much to complete, but we'll run to the breakout, we'll come back, and then there's one more application that we're going to do here based on the breakout 3 and taking an efficacy table and rendering it into the Shiny application as well. So 10 minutes, and then we'll come back and get to the last breakout here. All back here. So for this next section, there's actually no lecture in between this. Because what we're going to do is hop into breakout 5. I only have blank and I only have answers here because the task for this one is to pull the work from breakout 3, problem 5, to complete the application. So what I'm actually asking you guys to do here is to hop in and all of that pre-work, grab the grab all of the pre-work from this section of problem 5 continuing down below. So line 74 of the answers file. All that pre-work that you did down all the way to the bottom of the program. So breakout 3 answers, problem pre-work before problem 5 all the way through the end of problem 6, and pull that into your application. So you want to update your T-plier table with the information from breakout 3, so that you have the T-plier table, you have the custom metadata, and you have all of that available to pull in. You're going to put it before the UI. So from the Shiny context of when the code executes, it's going to execute before the application itself is launched, the UI and the server before they start executing. So you're going to pull that in. And what we're going to notice about this application is that the T-plier table changed, and all of that functionality is there, but we're still using the same server. We're still using the same UI. All of that other context is still the same, but we're going to use the work from the breakout 3 answers of what you produced, the custom metadata, and how that was expanded, and bring all of that in so that we can see the update into how that works in this application. So I'm going to throw you back into the breakout rooms. We'll just do another quick 10 minutes for this. So what I want you guys to get out of this is to now look at the code from breakout 3 and how that has impacted your application. Look at the code that executes. So when you run the, or look at the functionality of the application and how when you click around how the functionality of the application changes, with the custom metadata, look at what that produces in the subdata in the below table showing the data frame results of the input data. Explore that and see how when you update this, the functionality and the core aspects of this still remain pretty much the same, but what you're able to do and what you're able to expand with tplyr, now that you understand the metadata, now that you understand how tplyr is creating the table, now that you understand how you're expanding it so that you can see the flexibility that we've tried to embed into this. So we'll toss you into the rooms. I'll give that 10 minutes so that we can close out with the last 5 for some questions and some last thoughts here before we wrap up the workshop today. So I'll throw you in and we'll be back. I'll give it about 7 minutes this time because there's not as much work to do here. So 7 minutes and we'll reconvene. When you ran that last example, if this bottom table didn't show, if you zoom out of your screen a little bit, I have an external monitor here, so it fits on my screen, but if you're having any issues with that, just try zooming out your view a little bit, and then you can see the updates as they process here. But that is all the work that we have for today. The parting thought that I'll leave you with here is that in the Shiny application and the functionality that we introduced in here, with the JavaScript components, this is to work with Reactable. Different applications and different tools will have different mechanisms of talking back and forth between the UI and the server. So this is something that I hope we can expand more and learn more about as we have different on-click interfaces. And so I can't speak as much to how this might work with other things, but I'd love to see on-click functionality in GT at some point, so on and so forth. So the question from AJ about validation documentation for these packages, we actually did do a qualification effort for tplyr. And there are a couple updates that we need to make to the document or the qualification kit that we have here. But before we did the latest release, I made sure all those tests did still pass. And you can find that from the README on the landing page of the package website right here. So you have that. Thank you, Phil, for posting that. So the recording of the workshop will be available to pop back in here. You can get the slides and all the breakout content from the GitHub repository right here. If you have any issues with tplyr, then you are free to report an issue right here. And in the course of the workshop, we did add one there that we can come back to update at some point for generating RTF files. The latest thing that I'd recommend is for you to check out the package GT, where you could put a tplyr table into GT, and then that has RTF generation capabilities. And I would love for that to become the dominant force for that, but we also have our package Pharma RTF, which is primarily compatible with the table library Huxtable. The table library Huxtable to produce RTF files. And again, the GT, when we wrote Pharma RTF, that was back in 2020. It came out before tplyr did. So GT had not really yet supported Huxtable in totality, but Phil has been doing workshops with that to produce or to demonstrate using GT and creating RTF files. If you want to see a little bit about creating RTFs, this is our replication of the CDISC pilot, which predates tplyr and we wrote Pharma RTF in the process of doing that. Cable will work with tplyr to produce HTML tables. So Cable Extra and Cable, that's actually what most of our vignettes use to present the data. There's a lot of different styling libraries out there. I don't know that Cable supports RTF files. I don't think it does, but not that Huxtable. But Huxtable is another really great table library for that as well. But again, I will nudge you towards GT because this is supported by our studio and has been making rapid progress, including RTF file generation. And Rich has put a lot of work into that and works a lot with, so here are the export functions for that, has been working with the pharma industry and developers in pharma for quite a while now for doing this. If you haven't signed up for the clinical reporting in our workshop that's coming up, that workshop will cover more contextual examples of using R in creating pharmaceutical tables and using R for the clinical reporting pipeline. Christina Fillmore and Thomas Knightman, Christina from GSK and Thomas from Roche are going to be doing a lot of presenting about using Admiral. Christina is actually using, in that example, tplyr and some custom sections of that we've cut out to help support some future development with the GSK package called T-format and what might eventually become a successor for tplyr to show some different styles of that for some other and more advanced formatting capabilities to go right into GT tables and leverage that. So development will go on, things will continue to evolve. That's the great thing about the R world. But I hope you learned a lot about tplyr today and about some of the new functionality that we're trying to introduce. Our goal here and the philosophy that I've tried to embed here at Atorus is that for R to flourish within the clinical reporting world, we need to meet the capabilities of today and do the things that we're doing today, but also open up the door of what we can do tomorrow. So the message here is trying to get from the page to the screen. So we want to give you the capabilities that we need to create those CSR tables and the kind of fundamentals of what we do in our day-to-day, but also open up the door to give it something new, something better that we can do to take a step forward. And that was the vision of this metadata framework. So thank you all for coming. Thank you for your participation. I had a great time conducting this for you today. I think this is the first time that I properly timed a workshop for 4 hours, the first time through. So I'm also pleased with that. I think I put all the materials into the chat. That GitHub repository of the materials will stay up indefinitely. I'm not going to take that down at any point. It has a RENV lock file. You're able to create the environment yourself as needed. We're going to take down our Studio Cloud environment. I'll need to talk with Phil about how long we can leave that up, but generally when I do this, I leave it up for about 2 days and then close it out. But again, the content is in the GitHub repository with all the answer keys, and you have all that. So I gave you the book down, or the package down. You have the tplyr GitHub itself. Thank you all. Have a great rest of your day and attend the conference because there's going to be a lot of great content at our Pharma this year. Thank you all very much.